Hello students, this video is about translations and rotation, so let's jump right in. Translations first. A translation is a shift or a slide, and a translation takes your original thing and it moves it over. Okay, or it could move it diagonally, but after it moves it's the same shape, only it's moved over. Now translations can be described by a vector. Okay, a vector that which tells how much to move in each direction. And how you know it's a vector is instead of having parentheses on the side, it has these arrows on the side. So these arrows here are what lets you know that it's a vector and not just a point. So, for example, let's see, what would the image, find the image of z under the vector 3, -2. Well, here's the point z. This 3, the first number in the vector, tells me how much I should move in the x direction. And the -2 tells me how much I should move in the y direction. So this tells me about the x, and the -2 tells me about the y. So I'm going to start at where they tell me at z here. I'm going to start at z. If I start at point z and I move 3 in my x direction, +3. So here's my x-axis, right? So x is this way. So starting here, I'm going to go 1, 2, 3. And then I go down 2 in my y direction. 1, 2. It looks like I end up right here on point Q. Where do I end up? The answer is I end up at point Q. And so on the homework sheet there, I want you to tell me if you start at whatever point they give you, where do you end up? Where's the point where you end? You can also say what vector you've moved. Now, next example, find the vector that describes the translation that takes M, and this arrow means we're moving from M to Q. So what is the vector that goes from M to Q? Well, here's point M. If I start from point M, I'm trying to move and end up on point Q. How would I have to move to go from M to Q? Well, I'll start with how much I have to move in my x direction. It looks like in my x direction, I need to move over 1, 2, 3, 4. So I need to come over 4. And then I need to come up 1, 2, 3, 4. Over +4, then up +4. So my vector is the vector that has +4 in the x direction and +4 in the y. This is the vector. And remember, when you're writing your answer, don't put commas on the sides, because we're not talking about the point 4, 4. We're talking about the vector that moves over 4, up 4. Okay, transformations can be written as a matrix. So if I have points like point x1, y1 and point x2, y2, I can write them in a matrix by stacking them. So I have x1, y1 on top and x2, y2 on bottom, and I would just keep on stacking down. When we're writing it as a matrix, we use brackets on the side instead of parentheses. So we have the arrows for vectors, we have parentheses for points, and now we have brackets, which are for matrices. So let's see if we can take this blue trapezoid and transform it by a transformation. Let's see if we can do a shift of the vector -3, 4. All right, so now I could just do this by taking each one of these points, right, and just counting over -3 and up 4 and putting where the new point goes, right? However, I'm going to do this using matrices. So in order to do that, first I need to define where each of these points are. So let's just go ahead and count out where they are. Okay, so now that I have the values for where each point is, I can write these as a matrix by stacking the points. And it does not matter which one I put on top or what order the points go in. They can go in whichever order you want. I'm just going to go around. Okay, so here is a matrix that represents these points. So now I've got this matrix. I need to create another matrix that will represent the vector -3, 4. So I know that I'm going to take this -3, 4, and I'm going to have to add it to each one of these points. So my vector that I make needs to start with -3, 4, but it needs to have -3, 4 4 times because there are 4 points there. So I'm going to need to add it 4 times, the same number of points. And this is my translation matrix. So now if I take these two matrices and I add them together, I can get my answer. What we're going to do is just add the numbers that are in the same position. The numbers that are in the upper left-hand corner will be added together, and then these two will be added together. I'm going to add each of the two that are in the same position. So -2 plus 3 is -1. Okay, so when I add those together, here's my solution matrix. Okay. So let's go ahead and graph the points from our solution matrix on our diagram. So the first point for the solution, this is my x value, this is my y value, so the point -1, 5. And go ahead and graph all the points, and we can draw in our solution. Okay. And last, let's talk about reflections. So, a reflection is like your face in the mirror, right? You see the reflection image of yourself. It looks the exact same as the other, only now it's kind of been flipped over. Okay, so when you're doing reflections, I want you to do first is draw in that reflection line. Now, where does that line go? If you have x equals, that means that you're going to have a vertical line, okay? A line that crosses through the x-axis. And if you have y equals, that's a horizontal line, okay? A line that crosses the y-axis, that crosses it. All right, so let's look at this first one. Let's draw the reflection line. A line over, and we're going to see if we can reflect over x equals 2. Because I have x equals, I know I'm going to have a horizontal line. So I'm going to come to my x-axis. Here's my x. Up here's my y. Okay. I'm going to come to my x-axis, and I'm going to find the point 2. 1, 2. Now, I'm going to draw a line that crosses the x-axis at that point. Okay, because it says x equals, I need to cross the x-axis. So I'm going to cross the x-axis like this. Okay, my marker is dying, but hopefully you can see this blue line right here is the line x equals 2. Now, what you're going to do is you're going to move each point to an equal distance on the other side of the line. And the key words here are equal distance. However far it is on one side of the line, you're going to make it the same distance on the other side of the line. So, this point right here. It looks like right now, how far is it from the middle of the line, It is 1, 2 spaces over. So since it's 2 spaces on this side, I need to come 2 spaces on the other side. Okay, so 1, 2, 1, 2, right here. So now down here, this point is directly on the line, so I'm going to keep it right there. It's not going to move anywhere. How far away from the line is this point? That point is 1, 2, 3 spaces. Since it's 3 away from the line on this side, we're going to make it 3 away on the other side. So now I've got my new points. I can just connect them to get the triangle. Now let's see if we can reflect over the x-axis. Alright, now this time I don't have x equals. It just says x-axis. Well, the x-axis is right here. So if I were to reflect over the x-axis, I'm reflecting over this line. How far away is each point from that line? This point is 1 above the line. So I'm going to come 1 below the line. This point is 1, 2 above the line. So I'm going to come 1, 2 below the line. How about this one? And this one down here. This one is 1, 2, 3, 4, 5 below. So I'm going to come from the line, starting from the line, 1, 2, 3, 4, 5 above, and connect my points. And there is my reflection. That one's kind of cool because it overlaps. All right.